Okay, so yes, as Eduardo has said, this is my first talk, so don't mind if I'm a little bit nervous. I will do my best. And yes, today I will talk to you about signals, because when I first heard about signals, I was really interested in them, but I didn't really know what they would mean in the world of Angular. Because I didn't use any other frameworks that has them, like maybe React or Vue. So I really wanted to understand what was under the hood. So how do they work? Why would they be revolutionary? And also was very interested because on the internet you would find two very different factions. One that said, oh, Angular will use signals and nothing else, so RxJs is done, it's over. And the other that said, oh no, signals are, I don't like them, I won't use them, which is a debate that is still going on, at least a little bit. So I really tried to understand what they would mean, how they would work, and I hope that my findings today will help you when you would use them, or if you already use them, to better understand how and when it is the case to use them, or instead use maybe observables or RxJs. And also my rubber duck was very tired of hearing me repeating all my talks, so today you will be my figurative rubber ducks. So let's start with the beginning. Why did Angular decided to include signals into the framework? Was it because of these new trends? So all the other cool kids frameworks use them, so yes, we have to include them? Well, no, of course not. I think the thinking behind this process can be seen by this quote of Alex Rackable, the tech lead of the Angular team, which states that the nature of web applications is always evolving, the performance requirements evolve, and the web platform itself is evolving. So Angular needs to be stable but not stagnant, which says a lot also, as we've seen recently with the version 17 of Angular, that Angular is always evolving itself and trying to stay up to pace with its users and with the times, but also never breaking changes with the past. So it all started with the user's request. This is the first PR with the RFC, in which the Angular team explained the process behind the implementation of signals. And in this RFC, they explained that every year Angular does a survey in which it asks users to say what they like and what they don't like about the framework. And they took all of 10 years of these feedbacks, and they took back what the most requested features were. From what all of the users said, the most important things were that they wanted a finer control over the components and how they updated, overall better performance, simpler to use code, and an easier first approach. As we all know, Angular sadly has a bad rep for being a framework with a high learning curve, because you must always have to learn, start to learn Angular and also RxJS and NGRX with it. So it's not very beginner friendly, let's be honest. But also they wanted it to be glitch free. As of today, it is not. So all in all, this can be summed up into more activity. But reactivity, reactive, we all keep hearing this word, and I kept asking myself, okay, what does for a framework to be reactive? What does it mean? If I think about reactive, I think about a person that when you throw a ball against them, they catch it. Not in this case. Nice 90s reference if someone gets it. Loved it. And also, a framework that is reactive is something that when you click on a web page, maybe on a button, that the change gets in all of the other components, like it's immediate. So why Angular is not reactive? Searching on the deep web, I created a reactivity shopping list based on the frameworks that are truly reactive, like Solid.js or maybe libraries like Preact. And I found out that to be considered truly reactive, the framework needs to have immutable data structures, which means that you cannot modify properties on the go. It needs to have a unidirectional data flow that goes only one way. It needs to be glitch-free, which I will explain in a moment, and to have fine-grained control over components and how they update. To explain glitch-free, well, because Angular is not glitch-free, so I would like to show you a little example. If the internet gods are by my side, they're not. Okay, so we all know that Angular tries to be as glitch-free as possible, but especially if we use signals, we cannot have complete glitch-free. So if we see this example that you're not seeing. Molto bene. Okay, as you can see in this example, there is a counter observable which has an initial value of 0, and then you have isEven observable which gets its value from the counter and says if it's even or odd, and console log with another observable that says the counter value is even or is odd. So we have a starter message subscribe which will say, okay, observables counter 0 is even, and then if we update the value on the next line with next one, we will expect observable counter 1 is odd, right? No. We have observable counter 0 is even, observable counter 1 is even, and observable counter 1 is odd. This means that it is not glitch-free, as the values don't get updated in real time all across the application. So, coming back to our shopping list, we can also see that Angular does not immutable data structures. As we all know, it is based on JavaScript, which has mutable data structures, meaning objects and arrays. Also, we have, by default, the bidirectional data flow, which is useful, but it's not very performance effective. And we don't have fine-grained control. And the reason why we don't have fine-grained control is because of Zone.js. So for those of you who don't know exactly how Zone.js works, let's say that Zone.js is the library that Angular uses by default. It is useful because it checks for the updates and the changes inside of the application, but the downside is that it does a lot of cycles, and every time something updates somewhere, it doesn't know exactly where, so it updates all of your application every time. So you can see that especially with large applications, it is a great performance loss. Another solution is to use the Zone.js with on-push strategy, which means that every component, when there is a change that needs to be done, uses the mark4check function, which raises a flag. That flag says, okay, Zone.js, on the next detection cycle, check this component because there has been a change. So it is a little bit better performing, but it's still not the best, because even if a component raises the flag to be checked, also its parent components get checked. Instead, with signals, we will have only the update on only the component that we want and we need to update. So what are these signals? I've talked, I don't know, 10 minutes so far, but what are they about? Why do we have to care about them and how they work? A signal can be considered as a box, but what's in the box? There's a value. So you can always look inside the box, and at every time you can see what is the value inside. I like to think to access the value, you have to write the name of the signal and then add the parentheses. So I like to say, okay, I'm peering inside of the box to see the value, which is silly, but you remember silly things, so now you remember thanks to this. And this box tells the observer that wants to know the value of the box when it has changed, like maybe, I don't know, vibrating like a cell phone, and it says, okay, my value has changed, so check it out. Based on the fact that a signal always has to have a value, you always have to initialize it. If you don't, it will have an initial value of undefined, and that is against the purpose of using signals. So always initialize your signals and don't do drugs. Main takeaways. So, signals. How many types are there? Well, mainly two and a half. The main one is the writable signal, which is the one that can be changed. So we see that count has an initial value of 0, so we can change or update its value. Then we have the computed signals, which are read-only, because they get their value on other signals on which you can apply operations. The computed signal is useful because it can do complex operations, because it would not be re-evaluated unless you read it. So, for example, if we say that double count is based on count, but we don't use it anywhere in the app, it will not re-evaluate it no matter how many times we update count. And the other one is the effect, which is not a signal per se, as it does not have a value, but it does some operations depending on the signals it is based on, and it re-evaluates every time the signal it is based on is updated. Also, as we said that computed does not get re-evaluated unless we read it, effect instead gets, it runs at least once because it is tied to the template, so at least once you will see, for example, in this case, the console log. Also, in the effect, you cannot set a signal to a new value. Well, you can, but you shouldn't. So I had an example, but I won't show you how, because from great powers comes great responsibility. But how can computed be glitch-free? If they get their value from the signals and they update almost immediately with their value, how can they be not glitch-free as are observables? Well, this is because they use a push and pull protocol. This is, of course, a watered-down explanation, but let's say that this protocol to updating signals, it's based on two phases. The first phase, if we consider a producer, which is the one that has the value, and a consumer, the one that is listening for this value, for example, a signal and a computed, when the signal gets updated, it sends a notification to everyone who is listening, to it. So in this phase, there are no side effects and no recomputations of derived values. So no computeds and no effects gets updated with the new value. They just receive the notification, hey, my value has changed. So watch out because there will be some changes. The second phase, the pull one, is the phase in which the consumer then can finally pull the latest updated value, and in this case we will be sure for certain that the value is the one that we want. I have another example to show you, but I'm afraid that if I... Okay, I will show you because that's cute. Okay, so here we can see another really original signal named count and another original computed name named double. So we can see that computed gets its value multiplying by 2 the count, and an effect quick console logs the value. So we will expect, as I said, that the effect will run at least once with the initialization of this page. So we will have double value is 2 by 1, 2. If we had observables, we would expect double value maybe is 4 and then double value is 10, instead of having only the latest value of the signal. Instead, with signals, we will have double value is 2, which is the first console log, and then double value is 12, because signals have to wait that the function in which they are updated has to end before, before the computer can pull the last effective value. Okay. That was the last one, I promise. Okay, but by now you might say, okay, glitch-free is cool and all, but I don't care about it. So why can't I just use observables? They seem pretty similar, don't they? Yes and no. So for those of you who really don't know very well what observables are a collection of data objects, and that gets sent to the observer in a span of time during a stream of data. With a silly example, we can see the observable as the operator manning a drive-through window that gives packets of data objects to the consumers, and every time a consumer gets by the window, maybe they have to wait a little while, and when the observable says, okay, here's your package, you can go home and take it out of the package and read it. So yes, here is a small table to see side by side some of the differences. Of course, as we've seen, signals, they're synchronous, so they're not affected by time, as we can always at any time read their value. Remember, peering into the box at any time. Instead, observables are asynchronous, so they are available only when a new value is pushed, so they are affected by time. So you drive by the drive-through window and you have to wait for the new value or the new package to get sent to you. The subscription is explicit in observable, as is the unsubscription. So we all know that if we don't unsubscribe from our observables, we will incur in really, really bad problems. Instead, with signals, this subscription and unsubscription is automatic. This is done so by the getter function. So whenever someone is waiting for the value of the signal, it will automatically subscribe to the signal. The data is directly available in the signal instead of the observables. As we know, it has to be extracted. And also, as we said, observables are not glitch-free, whereas signals are glitch-free. Okay, so, well, of course, signals are better than observables, right? Right? Nah. As we all know, and we all love as developers, it depends. It always depends. They're different because they do different things. So if you have values that change, but they're not affected by time, we have to use, well, it's better to use signals. Like, for example, if you have a form validation status or some ruler parameters, whereas if you have a stream of events that change over time, it's better to use observables, like, for example, HTTP client, or event emitters like keyboard clicks or mouse clicks. So always the right tool for the right job. Also, this field is really meaningless because already RxJs has done some interoperability with signals to transform observables to signals and signals to observable, and also is really recent, the one that is the select signal that gets you a slice of the store, which is already a signal, so you don't have to transform it into a signal. So let's talk about the real important things. Can you add fresh cream to carbonara? Oh, good people. Bravi, bravi tutti. So now the juicy part. Here I have some little examples. Of course, they are small. They are part of a bigger application made by another content creator, which is Deborah Curata. She's amazing. So if you're interested in Angular, she has a really awesome YouTube channel. So go check it out. after this talk. And this is based on e-commerce app, and I've taken the cart total components and the cart service components, in which we examine the signals to get the total of the items in the cart and how they are removed or added to the cart. Of course, there are snippets. So for the simpler part, of course, the app was made firsthand with the observables, and then it was made using signals. And as you can see, in the one with signals, of course, you cannot see such difference in the TS file. But maybe if you're a newbie, at first you may be scared to see, okay, why does my variable have a $sign at the end? What is this, PHP? No, okay. So for the HTML, this is a bigger difference. As you can see, we won't have to use the pipe async anymore, as we learned that every time we read the value of a signal, the subscription gets, it's automatic. So what we got from the pipe async, we got for free just by peering. And also the really nice management of the undefined part. So we see that cart items dot length, we don't have to use the question mark. So because we know that we have to initialize our signals, that's why. Because if we don't initialize it, it's useless. Also, the fact that we don't have to use the pipe async is really useful, I think, because if we see on the third line, we can see that we have pipe number, for example, and we have, if we had other pipes, well, it's less visible clutter. This is the biggest example, the cart service. This is the before with the observables with 87 lines of code, because we all know we like numbers. And this is the after with 57 lines of code. Of course, not always less lines of code mean better code, but in this case, it is. Some zoomed in snippets from the cart service is that, for example, the total price, we see there is a big difference. Like, again, I try to put myself in the beginner shoes, because I was not so long ago. And when you're faced with so much operations in RxJs, it's kind of disconcerting, because I just wanted the total price. Come on, it's not that difficult, but it seems very difficult. So with signals, it would be so much easier. Also, here we have the remove from cart. And on the first example, we will see with the observable, we have to pass through a subject and give it another value, and then the item that we want to take off, and then the action that we want to do. Instead, in the remove from cart, we say, okay, the cart item signals update without the element I want to remove. Easy peasy. So this is the complete function that we have removed from before. This is the unfamous 30 lines of code. So we can see this is the upper part, in which we have a subject, because we want to have multicast, but we want to make it private to not modify it directly. So then we have to convert it as an observable to read it outside. I won't bother you with details. If you want to ask me, we can talk about it later. And also for the item action, that's what we've seen before. It gets the action that we want to do, like add or remove. Because in the next part is where you have to get the action and do, like if you see at the end, you can see that the else if operation action delete return items filter, which was what we did in the signal in like 2 lines. So I'd like to have some final thoughts about this. As we've seen, we can definitely say that the user requests from the beginning have been totally answered, because we have, with signals, we have an easier to use framework. We have less code to be used, better performance overall, a finer control over the single components. We will have finally glitch-free synchronization of values. So That's nice. And overall, this means more reactivity. So yay, Angular is truly reactive finally. But it is important to note that we will not substitute observables completely. More likely, we will manage the backend with observables, as we've seen that signals don't play well with asynchronous operations. And then we will convert the data that we get from them into signals to manage in the template. So that's it. You're now free to go. So now that that I got your attention, I'm Daniela Bonvini. I'm a front-end developer at Spark Fabric, and this is my LinkedIn profile in a cool QR code, but also written because I feared that QR code may not work, and also the joined-in QR code for the evaluation. So please be nice, like constructive criticism, please. Also, I would like to thank you, the groups, for giving me this opportunity, as this was my first talk, as I said. And also, I would like to thank Spark Fabric, which is our company, that pushed me out of my comfort zone. And I'm really happy to be here. And if you'd like, check out our careers page. We're always searching for new people. So if you'd like to do this, come work for Spark Fabric.
Okay, thank you, Daniela. I have a question for you made by an artificial intelligence. So, as you can convert observables into signals, how could you handle errors?
That is totally unexpected.
I don't know, it
It's
just popped out in my phone.
Such coincidence that I have a stack blitz about this.
Wow, you're such an experienced speaker.
I know. Okay, so yes, I made this little stack blitz because I thought it was really interesting, and also I wanted to use the new control flow syntax, which is so nice, and I didn't have the occasion in my day-to-day work. So as you can see here, we have the service in which we make a call to a generic JSON placeholder to get some users. And then the way you can manage errors is that you can create a new type of result which has value or data or whatever you want to call it for the data that you receive, and also an error property which will handle the error. So here you can say that we have a map for our result. So we have result, and you will say, and you will get there, and error is undefined. And if we have an error with a catch error, we have an observable with undefined value, and of course the error. I set an initial data. You didn't have to, but I wanted to get the empty array, because if I do this, it should update. It is not updating. Ah, yes, because I wanted to do this. That's silly, but I wanted to. And also we can see the error handling. So if we modify the backend, we can see that it's loading, and then we get the error response. So that's how you handle errors. Also, you could use try catch instead of a computed, but I don't have a stack blitz. I know you're all very sad, but I don't. So that was it.
Okay, thank you, Daniela. Any other user-generated questions? Don't be shy. I see a hand.
As you said, signal doesn't need to be unsubscribed, but does it work both for computed and effects? Because,
yes.
Okay. Because for computed is quite clear because it doesn't get consumed anymore. But I was thinking about an effect. We rely on a signal from another service, so that is still alive. I didn't know if I had to unsubscribe somehow, or if
No,
it was
that gets automatically, as far as I know, it gets automatically
Okay.
unsubscribed.
Thank you.
Oh, by the way, I like the new rectangular syntax of Angular 17, but okay, it's not
The AI
related
was
to
right.
that talk. No, I would like to know, because I don't know Signal very well. Using this kind of syntax, you go away from zone, or at now you are always in zone. So for Angular 17, this is simply a new syntax, and this does not have performance improvement.
No, so far you have to use Zone because they always want to have retrocompatibility for a good couple of years or even more than a couple of years. So as of right now, they are developing signal-based components. But as the latest tweet I heard from Minko Gechev, which is one of the tech leads, he said that it's still in development and they never say in which version something is going to be. So as far as I know, maybe in 18 they are working on it, so it should be in 18, but I won't say. So signal-based components should be, I don't think they will be completely zoneless, but they are thinking about going zoneless in a very far future.
We have a question from home.
Yeah. So, Signals seems a cool addition to Angular, but since it is not a replacement for observables, isn't it an extra difficulty in learning Angular? Instead of using only observables in an application, we now also have to decide when to use signals.
Well, okay, I never thought about it. But it depends. Like, if you're starting, you won't get to have many difficult things concerning backend, probably. So you won't have to use all the difficult RxJs operations like, combine latest or scan or share replay or something like that. So probably you will all just use RxJS to get the calls from the backend, like in this case for HTTP requests, then convert it to signals and just use signals, which are super easy to use because you have, as we've seen, just 3. So you use computed for you use the basic one for the values, computed for operations on the values, and then the effects mainly when you want to debug or do something else, but you won't use it that much. So I don't think it would be that much of a hurdle.
Nice talk.
Thank you.
About the glitch-free, signals being glitch-free, we saw a very interesting example of many set values, one after the other. And I was wondering what happens if I try to read the value in between one of them.
Well,
I get one, or I get the last value that was set.
You will get the last, but you cannot read it. I think you cannot read it because if you get if you have a computed, I get the example that you're talking about. If we had the computed, you declare it at the beginning of the application, yes. So you don't put it inside of a function.
Yeah, no, absolutely. I was just wondering because we are comparing signals usually to bare observables. But from what I see, a signal is more or less a behavior subject in RxJS with an automatic debounce.
Yeah, kind of.
So basically, I don't get the synchronous emissions. I get subscribing directly to the behavior subject, but I get only the last value that was set in the current tick.
Well, it works in a way similar to the behavior subject, but also in a way which is different, which was the push-pull example. I know it was kind of difficult to explain it because it was like 2 pages on the PR, which I read it. But as far as I tried, because I tried to do what you said for putting a computer inside, because but I think it is made in a way that it always gets the last value, because it always gets to the latest value available, so all of the notification, and only when the notification that the value is updated, it will pull the last value. And also a nice thing is that it also does an equality equation, equality check to see also if it really has to pull the value. So the signal will always tell its observers that its value has been updated, but when the subscribers, let's say, pull it, we'll see if they really have to reevaluate. So if the value was true and it is again true, it will not pull again, because it will see that the memoized value it has is the same. Okay. So, but for your example, maybe if you want, if you contact me on LinkedIn, I will send to you the PR I read from the push-pull example. So it really is nice. Maybe it will explain something that I couldn't.
Yeah. Okay. Good morning. Kudos for the presentation.
Thank you.
Excellent. I'd like to ask about the glitch-free property, and probably aside from Angular, if it's possible to reach an asynchronous value with glitch-free property. With probably, I don't know, maybe with another technology, another framework or something.
Okay, I really don't know.
No?
It depends. It depends.
It depends.
I have one more question. Sorry, I have one more from home.
No, I think she wanted to answer. Maybe no. No. This last one. No. It really depends.
Really,
okay.
Right now, I can think of one, so I'm gonna be honest. I believe in honesty.
Okay, maybe we have time to.
Is it possible to combine signals with NGRX? Which are the advantages?
Yes, they just released the NGRX/signals, which will use signals to manage the store. So, well, the component store. But I know that someone else is going to talk about this in the later talks, so I won't give any spoilers.
Okay, maybe one last one.
Hi.
Hi.
About effects. Okay, we know that inside effects it's a bad practice to write signals.
Yeah.
But if we use NGRX to handle state, to manage state, and if I need to dispatch an action inside the effect, now Angular tells me that I shouldn't write signal inside the effect. But if I dispatch an action, the action really do a call to backend to fetch data, and then write signal. So it's a hybrid. It's not synchronous. It's a synchronous operation. Why? Why Angular tells me that I cannot write signal, that they shouldn't write signal.
Well, I think they wanted to really be sure that people didn't update signals instead of effects, because as we all know, as developer, we always do the wrong thing for fun. So they really wanted to be sure that you didn't. Of course, they are still, well, they are officially released with the new version of Angular, but they are still in working in progress. Like, for example, it is not in the case you're talking about, but as I was reviewing the slides, for example, to set the signal, there were set, update, and also mutate. But they took away mutate in the last couple of months, because they're always analyzing what is good and what is not, like in this case, for being sure that it was immutable. So I think they're preferring a stricter way of doing things right now, get the feedback, and then after they're certain that people are doing the best practices, as we know, there are still no real best practices. They are being developed as we speak. I think later maybe they will be a little bit more mellow with this.
Thank you, Daniela. I think we stressed you long enough. So thank you very much. Thank you, Daniela. you.